I'm a retired wildlife biologist, and I'm actively involved in both Wisconsin Green Fire, which is an organization that promotes sound science in natural resource management, and I'm actively involved also with the Timberwolf Alliance that has promoted education about wolves to teach people more about wolves to improve coexistence of wolves. So what I want to talk to you about this afternoon will be about wolves and how we can use numbers to assess their ecological impacts, to determine various conservation conditions and things about wolves. And before I go on any further though, I'll give Karen a chance to introduce herself.
Hey, I'm Karen Messmer, and I taught middle school and high school science, mostly biology, in Alaska and Europe for over 30 years, and I'm a science ed consultant. And I'm going to do a couple of things with Adrian here. I also work with Green Fire to kind of give you an idea of how you might use the information from scientists such as Adrian and other scientists from Green Fire in your classroom. So if you look at the handout I gave you, this is just a reminder that what our students should be doing in the classroom is figuring out and making sense. It's not just us telling them, but they should be doing some of those practices like asking questions, which is something I'm going to have you do at the beginning here, and tying things together with cross-cutting concepts. And then I listed on the next couple of pages some of the DCIs that you might choose to use with wolves. And so in just a minute here, we'll look at a phenomenon, because when we start out with a phenomenon, the kids need to figure out how to explain this.
I have a problem with the matching up with Do you want to say any more about this?
So this is a phenomenon. Here's some data about where wolves have been detected in Wisconsin in winter 2019 and 2020. So I want you to take a look at this map, this data, this phenomenon, that this is where we find wolves. And I want you to come up with a question that you have about this. And yes, this can go many different ways. Our driving question is going to be what effect do wolves have on living things in Wisconsin. So that's what we're going to concentrate on this unit if you're teaching it in a classroom. But I want to give you a chance to ask a question. I don't think we'll have everybody come up this time. If you want all your kids to have some kind of say, what am I going to wonder about this particular phenomenon? Something about wolves from that. So take a moment to write down a question. And if you get a question written down, we'll take, some people can come up here and put their question on this driving question board that you can move up during the unit, and then address all those questions in some form or another, because these are things that kids are interested in by the end of the unit. So come up with a question, something that you have about that data.
So what I'm going to do now is kind of go through some statements that I have up here. Are these statements true or false? How can we examine these with our students? And these are kind of statements I've gotten out of news releases, news stories, quotes that people have made, and somewhat paraphrased, but things like the Wisconsin wolf population is exploding, is out of control. The wolves have killed and eaten most of the deer. There are a few deer remaining in northern Wisconsin. Wolves are a major threat to our pet dogs in Wisconsin. Wolf damage compensation is soaring in Wisconsin. Wolf hunting season will cause wolves to again become endangered or disappear from the state. Allowing lethal controls on problem wolves will decimate the wolf population and cause wolves to again become endangered. And DNR doesn't know how many wolves there are in Wisconsin. There are many times more than what the DNR reports. So I want to kind of examine these with numbers that you kind of assess some of these things. So just a quick review of wolves. Gray wolf is the largest member of the dog family. A Great Lakes gray wolf, that's a little bit smaller than western gray wolves. Males average about 80 pounds, females about 70 pounds. They stand about 28 to 33 inches at the shoulder, so just a little bit under 3 foot in height. Compared to the coyote animals most often confused with, they're quite a bit shorter animal, only about 20 inches at the shoulders, typically weigh only about a third the weight of a wolf. Color-wise, it can be a little bit different, but it's more the proportions. Ears proportionally are much larger than a coyote, so a 30-pound coyote actually has ears the size of an 80-pound wolf. They have a much more pointy face and a longer tail. So you can see some of these characteristics when you see them in front of the trail camera. So just to also remind folks where we're living, where we are right now, was a home for various nations, different nations, 250 years ago. And so we're right kind of at the intersection of where the Menominee and the Ho-Chunk and the Fox and the Ojibwe people lived. And we had the Dakota people just to the west of us, and Potawatomi people to the east of us. And for most part, Native Americans were fairly compatible with wolves on the landscape. Many of them, wolves are an important part of their culture. But throughout the time of when Euro-Americans started settling into this area, we had a constant decline in the wolf populations. The state of Wisconsin had a bounty system paying people to kill wolves that lasted from 1865 to 1957. So there may have been 3,000 to 5,000 wolves in what became Wisconsin 200 years ago to totally disappearing from the state by 1960. And throughout the 1800s, late 1800s, early 1900s, that population was declining. So they disappeared about 1960. They started coming back again in the mid-70s as a result of the Endangered Species Act, both the state and federal Endangered Species Act. So when wolves did return to Wisconsin, starting in 1979, 1980, Wisconsin began our starting formal monitoring program of the wolf population. And so, how are wolves counted? Well, basically the counting is one pack at a time, individual wolves. So the method that's probably kind of the gold standard for counting wolves is having the animals radio collared and then flying in on them from the air. So wolf number 3 in this group is radio collared, but you can easily count all the wolves in this group with having that collared wolf in there. And you wouldn't be able to locate animals like that on the landscape unless you had a collared wolf that could lead you to them. So this is kind of the gold standard for counting wolves, but you can also do a pretty good job sometimes at snow track surveys and just driving down forest roads. So we see where these 7 wolves are walking parallel to each other down this forest road. So just carefully driving down roads can be a way that we can get additional counts on wolves. And then with the trail camera, it was becoming very popular in recent years. This is a case in Fort McCoy where some baits were put out, wolves gathered at the spot, and were able to get a good count on the wolves that way. So when you add these up, we're looking at an area in northwest Wisconsin. So the blue packs are packs in which they were counted by these snow track surveys. The yellow packs were animals seen from the air, but at least one member of the pack is radio collared. And sometimes you don't get an exact count, so there's a range in counts. One time you get 7, next time you get 9. You weren't quite sure if you saw several animals over again. So sometimes the pack number is a little bit of a range. But within this area, we have 24 packs with 90 to 98 wolves, or 3.75 to 4.8 wolves per pack. And when we look at the size of this area, it's about 1,900 square miles. And an average wolf population will have anywhere from 3 to 15% of the population may be loners. So if we add 5 loners to this population, we've got about 95 to 103 wolves over this area, or about 1 wolf for every 18 to 20 square miles. So at a relatively low density compared to a lot of other animals, and is typical for apex predators, they're going to exist at very low densities. And when you expand this across all of the state of Wisconsin, so this is a map from 2012, all of the packs that are shown as yellow were snow track surveys, the purple packs were packs seen from the air, the blue packs were actually snow track surveys, but then had been radio collared in previous years. So from this you can get a picture of the wolf numbers across all of the state, and it comes up to 795 to 820 in 213 packs, plus 20 loners ever detected. So it gives us a population of 815 to 880 wolves. So this is considered a minimum count of wolves. It's based on the animals we actually detect through these various survey methods. And the density is about 1 per every 13 to 15 square miles. So using this minimum counting system, Wisconsin has determined wolf populations from 1980 through 2020. In 2020, the state stopped using the minimum counting system, went to a new statistical method for estimating wolf numbers. So we've got 40 years of data. And so what we see here is a pretty good growth of that population from about 25 animals in 1980, the population growing very slowly, even dipping somewhat in the mid-1980s, but really starts taking off in the 1990s and early 2000s. We see a bit of a dip here, which was due to the hunting season. We'll talk about that a little bit later. But during this period, wolves were delisted when there were hunting seasons. They were off on the endangered species list toward the end here, and yet, without a hunting season, without any kind of lethal controls, the population is starting to sort of level off up there. So if you look at just a typical logistical growth curve, which is a common way we talk about growth of wildlife populations, especially those populations that are limited by carrying capacity, the growth follows this typical lag phase. It takes the logistical growth phase. There is a point of inflection where the population starts to slowly grow. The growth starts to slow down. Then you start getting environmental resistance, and as it reaches carrying capacity, the population levels off. We don't expect it to stay in just a clean line here. We expect some fluctuation, but it follows a typical pattern for a population that's regulated at carrying capacity. In contrast to a population with exponential growth, we just expect to grow until at some point that it just crashes. That's more common like with some insect populations and small mammal populations. So we see a fairly classical pattern there of the Wisconsin population. There was a study done in 2015 that estimated a carrying capacity of about 1,242 wolves for Wisconsin. Now, as I said, this minimum counting system was discontinued in 2020 when DNR went to a more statistical estimate for called patch occupancy modeling. And this method accounts for missing observations and unevenness of surveys, but it has a very broad confidence interval. And if you just take the mode of the patch occupancy modeling for 2018, 2019, 2020, it averages about 14.5% higher than this minimum count. So this is more of a truer estimation of the actual population count. The minimum count, we're always assuming we're going to miss some animals. But even that number, like the most recent estimate was 1,126 wolves with about a 95 credible interval from 937 to 1364. So that's a 95 probability it falls between those values. And there wasn't a minimum count done in 2021, but just assuming 14.5% greater than the minimum count would have been about 963 animals. So here we see again that the population is pretty much leveling off at this point. We don't see an exploding wolf population. We see a population that seems to be sort of stabilizing and stabilizing at the carrying capacity. So the next thing I want to talk about a little bit is the impact wolves have on the prey population, deer.
Okay, we'll stop here for a minute. So I see a few questions up here about reintroducing wolves to Wisconsin and about the habitat and what makes it good habitat for central Wisconsin or northern Wisconsin. Did anybody have a question about deer and wolves? Okay, what was your question?
I have several friends that have been hunting up north for years, and all of them say at their camps they're seeing just wolf tracks, and they rarely see deer anymore.
Okay.
Just related to this.
Okay.
And they used to be very successful in hunting.
So we have this question about, so what's happening with deer and wolves, especially in northern Wisconsin? So if you were to have your kids try and answer that question instead of you just telling me an answer, what else would you need to know? So I want you to think for just a minute for yourself. What else would your kids or you need to know to determine what's happening with deer and wolves in northern Wisconsin? And then I want you to share with somebody around you, whether you turn around or share with the partner next to you, about what other data, what other evidence, information do you need to know to help you answer that question. So take a moment and share with somebody about what evidence. Because it's good to have kids think, okay, how am I going to get the information? What do I need to know to figure out the answer to that question?
Maybe looking at deer kills per hunter in counties.
Okay, all right. What else did people say? That?
You want to know population density of the deer and the wolves and hunters.
All right. Any other things you need to know?
I'd like to do like a behavior study on prey species and how they respond to the presence of predators, all this stuff versus no hunters. There we go, the behavior stage.
Good.
Start on this one.
All right. Sure. Okay, so we've got some information that you'd like to know, and this is another place where Wisconsin's Green Fire comes into play, is that we will help you get that information. So I have some packets up here if you want some information about how to get in touch with us. That if your kids have some questions, you may need some data and you can't find it, we'll help you find it, because we've got scientists in our group that will work.
And we're going to make this PowerPoint available on both the international Wisconsin Green.
On WSST too.
The numbers and stuff I'm throwing out there, those will be available.
Okay, so let's see if what Adrian has answers some of your questions about what data you need.
So there were a couple of studies done in Wisconsin on wolf food habits, and there have been many others in other locations. The earliest one, I'm sorry that the red isn't shown up here real well, but Dan Thompson in 1952 was Ella Leopold's last graduate student before Leopold had died, but he did a study on food habits of wolves in the late 1940s before the population had disappeared, and he just looked at the frequency of occurrence within scats, and 97% of scats had deer, and so obviously deer were very important, but he wasn't looking at volume as much. And then in 1983, Matterman looked at wolf food habits, but looked at more of the bulk and volume of it, and 55% of the volume of deer, so a little bit less than when you just look at frequency. But this is the actual volume. And his samples were somewhat biased towards summer, so it'd probably be a higher percentage of deer even if you looked at the winter samples as well. And there have been research done within the Great Lakes region and estimates that the average wolf kills and consumes part of about 15 to 19 adult-sized deer per year per wolf in the Great Lakes region. That could be as many as 9 fawns in the study in Michigan, or 13 to 15 fawns in the study in Minnesota. They also may consume as many as 8 to 10 beaver a year, about the average. So what are their overall impacts? Well, this is an estimate of deer predators human kill across northern Wisconsin. So this represents mostly the northern third of the state and the kind of density. So black bears, we have probably 18,000 black bears across the region. They don't kill a lot of deer, but they kill about 1.5 fawns per black bear. So that comes up to about 27,000 deer that they're killing. Bobcats, we've got maybe about 3,800. They kill as many as about 6 fawns per year. So about 22,800. Coyotes, I have to admit here, this is a rougher estimate because we have actual surveys of black bears and bobcats. Coyotes is more of an estimate, but That's a reasonable estimate for their density. They kill about 3 fawns per coyote per year, but that comes up to about 36,000 deer. Wolves, the lowest number of the predators, but they kill a lot of deer, but still, the number of actual deer being killed by wolves is less than all the other predators. And then when vehicles, there's a couple of thousand there, and we put in human hunters, and human hunters kills about a deer about once every 3 years, about 180,000 hunters in northern Wisconsin that hunt in northern Wisconsin. So that's about 54,000. So human hunters are still killing more than any of the predators are. The total of all the predators would be more than the human hunters. And as a total of all these mortalities, about 159,000. So about a third of the estimated deer population, 376,000, exist across the area. So when you look at the total number of deer versus the total number killed by wolves, as a percentage, it's a fairly low percentage. It doesn't mean somebody having a deer camp in the middle of the wolf pack areas and seeing a difference in in the deer populations, but across the region, the impact is fairly minor. And we always want to talk about some of the ecological benefits from having wolf predation. There's a culling effect in the deer herd. There's a reduced,
Just look at the coyote and the wolves. From what I understand, wherever the wolves go, the coyotes get pushed out or killed, right?
Not totally, but generally wolves do reduce the presence and abundance of coyotes.
Does that overall help in the numbers, or?
That probably does. So I mean, if you totally eliminated wolves, there would be a lot more coyotes on the landscape, and they're killing a lot more fawns. So that's what I've got listed here. One of the others is that, yeah, wolves can reduce the presence of coyotes. In Yellowstone, coyotes are a more important predator on pronghorn fawns. Wolves don't even bother with pronghorns because they're so small. But by their killing coyotes, there's a greater abundance of pronghorn now in Yellowstone since they've introduced wolves. So they also increase the diversity of wildflowers, reduce browsing on trees and shrubs by moving the deer herd around. And there's a study recently that they even reduce levels of vehicle collisions. And this is just kind of an example of the trophic cascade relationship. So the wolves, their impact on deer reduces browsing and grazing. So in the middle of wolf pack areas have a greater diversity of wildflowers, less browsing on trees and shrubs. The edge of wolf pack areas where the deer concentrate more have more ferns, more grasses. The plants are less palatable to deer. So you have greater diversity of healthier growing forests in the middle of wolf pack areas. So wolf impacts on dogs. This is a common fear people have. We do have wolves killing dogs on a regular basis every year, but it's mainly hunting type dogs. And this is the growth of that during how many we see over the years through 2020. Most years, there's about 22 dogs killed per year, and about half a dozen or so that are injured. We see a big peak right here. That was mainly because of some major policy changes that allowed people to more readily hunt hunt bears with their dogs. And we see it go way down this year when there was a threat, when there was a court challenge to using hounds for hunting wolves, and it seemed like depredations were not being reported that year. So what's really happening, these are mainly hounds used for hunting bears and training on bears in July, August, September. So it's not the average dog walking in the woods throughout the year. It's a very specialized situation where these are occurring. And these are dogs usually running some distance from the hunters. And it's a time of year that wolves are very protective at the rendezvous sites. So when we look at pet dogs, and the definition here isn't so much the breeds of dogs, it's just how they're being used. Hunting dogs, those being used in hunting and training for hunting. Pet dogs, people just walking their dogs, or dogs around people's homes. And the numbers here kind of follows the growth of the wolf population, the levels of depredations. The gray are the ones that are killed, the green are those that are injured. Then it really levels off again. And I should point out a difference between pet dogs. Usually more than half are not killed. In the case of the hunting dogs, most are killed. The big difference is there's people there that intersect and yell at the wolves and scare them off. So, and what we see is that it seems to actually have declined. It declined drastically when wolves were off the endangered species list and there was flexible management, and it kind of popped up there for a while. But even here, where wolves are still on the endangered species list, it's gotten relatively low, and I think in part people have just kind of learned to live with wolves on the landscape. So what we can say about depredation of dogs is that the attacks are mainly on hunting dogs in summer, and when wolves are protecting their pups, the rate of attacks don't seem unrelated to actually the growth of the wolf population in recent years, since the 2000s. The extreme peaks and low points are more related to regulatory and policy changes, and pet dogs attacks in general are declining as people have learned to live with wolves on the landscape. So compensation, how much payments are made for depredation. Now, Wisconsin has a very lucrative or open system for paying for injured animals. I think we're the only state that pays for dogs that are killed by wolves. And there's been, since 1985, over $3 million has been spent on reimbursement for wolves. A third of that is for the hunting dogs. Nearly 30% are for missing calves, and Wisconsin has a fairly a system whereby people who lose calves if they've had no depredation get paid for their missing calves, a percentage of missing calves. So this is not verified animals even. Verified cattle gets down to 23%, and then it gets down to 6% for captive deer, and domestic pet dogs it's only a little over, it's only 3.5%. And what we see is that, the depredations especially increased as wolf depredations increase, like this is verified livestock. The peaks were about 2020-21. It comes down drastically when wolves are off the endangered species list. It comes up again when they go back on the endangered species list, but it doesn't grow back to the same high level. So that seems to be sort of leveling off as well. So what we can say is that, $3 million have been spent on wolf reimbursement, but the highest was $336,000 in 2011. It's been down pretty much since, and now it averages about $169,720 per year, and with peaks of since 2020, it peaked at $2,400. So it's not as high as it was 10, 15 years ago. Wisconsin does have a program that has a generous program paying for missing calves, and the only state that pays for hunting dogs. So those two figures alone take up a huge amount of that payment. And for most part, depredation of livestock had declined from peak years. So impacts of hunting seasons on wolves. We did have hunting seasons in 2012, 13, and 14. We had one in 2021. I'm going to mostly talk about those earlier ones, which were done in a fairly sustainable fashion. So there were 6 zones established across the state, and quotas were set for each zone. And in 2012, the total was 117. 2013, 257. 2014, 154 wolves were harvested. So what was the impact of harvesting that many wolves from the population? Well, the count before the first hunt was 815 wolves in 2012. That year, the department planned on having a harvest that was going to keep the population at relatively stable levels. 117 wolves were harvested. The count the next year was 809. So it did remain relatively stable between those years. The next year, because of depredations occurring, the department felt we wanted to reduce the wolf population by about 15%. So 257 wolves were harvested that year, and the population did dip down to 660 wolves the next year. So it did seem to sort of bring the population down. So that's a big dip we see in that graph of the wolf population. The next year, there was still a harvest, 154 wolves, and again was intended to stabilize the population, and instead it grew a little bit to 746 wolves. So a 13% increase. So what you see then is during its harvest system, it stayed stable that year, it declined this year, and this year it increased even while there was an ongoing harvest. So even with an ongoing harvest, the population still was able to rise. Now you see it rose quite a bit since then because there were no hunting seasons here at all. But even without the hunting season, we see it starting to stabilize there. But we can, what we demonstrate is that you can harvest wolves at a certain levels without depressing the population, even allowing some growth in the population. And the harvest is typically done in the fall. If you look at the way wolf populations change during the year, at the end of the year, this is when these counts are done, these minimum counts, the population actually doubles shortly after that, when pups are born, because the average pack has about 5 or 6 pups per pack. But then it starts leveling off again throughout the year. A lot of the pups don't survive, some of the adults die, and then you have that wolf hunting season that occurs during that fall period. Yeah.
Approximately, what's the average age of a wolf in Wisconsin?
Average age of probably 2-3 years. Pups typically, if they get to be a year or older, their annual survival is about 75–80%. But the first year, we probably lose 2/3 of the pups before the end of their first year. And the maximum longevity is about 13–14 years. So yeah, 2 to 3 is probably more average. So the overall impact of the hunting season, 3 years of wolf hunts and trapping resulted overall in an 8.5% decline in the winter count of wolves in Wisconsin. But during that same time period, there was an 58% decline in depredation. So there was more. Having more flexible management allowed the department to reduce depredations without drastically reducing the wolf population. And some people say we've got to get the population down to 350 wolves so we can control depredations. But what this demonstrates is you can have a reduction in depredation through various controls without having to drastically reduce the population. Hunting is used in most of the Canadian provinces and Alaska, Idaho, Montana, Wyoming, the U.S. And when it was used in Wisconsin, Michigan, Minnesota, when we were delisted 2012, 2014, and wolf populations can be sustainably harvested at about 22 to 29% of the winter population. So that's the period we're talking about. But ethics, ecological benefits, value judgments, and cultural concerns should also be considerations when we determine when, where, and how we're going to have a public wolf hunting season. So just a little bit about lethal controls and their impacts on the wolf population. Some people are concerned that lethal controls are going to decimate the wolf population. So the pink areas back here are when wolves are on the endangered species list, when there's almost no authority by the DNR, by the state, to do any lethal controls. The yellow and green are when the state management authority, which means the state can use lethal controls on depredating problem wolves. And what you see, except for this dip, which we discussed was part of that harvest, for most part, there's not a really drastic reduction in the wolf population growth when those lethal controls are authorized. And also that there is an extensive use of non-lethal methods that are used as well. And by USDA Wildlife Services, the agency that does most of the depredation control work in Wisconsin. So they use things like flattery, special flagging, electric fencing, clearing vegetation under electric fencing, noise-making devices, flashing lights, guard dogs. All of those are part of depredation management. This is an interesting situation where it demonstrates the impact of using non-lethal control. So here you've got a depredation occurring here, non-lethal control occurring shortly thereafter. The wolf causes depredation over here, then it moves to another location, and the wolves just keep moving around as the non-lethal controls are done. So that's a limitation of non-lethals is, yeah, it can move the wolf away from where it's causing problems, but it causes a problem in a new location. So within this pack area, there are 6 different farms over the course of this summer that had depredations, and every time a non-lethal control was used, it just moved the wolves to another location. So there is need for some lethal controls at times. And this graphic shows the level of wolves removed from farms, and the orange, those that are euthanized. And the numbers are low when they're on the endangered species list, and it's higher when there is more flexible management. But you can see even when they are being done, it generally declines over time because you've removed the problem wolves from an area. So what we can say about lethal controls, that generally less than 8% of the wolf population is removed by lethal controls, that generally less than 15% of wolf packs are involved in any kind of depredation, livestock depredation. And during periods of lethal controls, the wolf population continued to grow in Wisconsin. In And targeted lethal controls have been applied to wolf populations across North America without endangering wolf population, and generally an integration of mixture of lethal and non-lethal controls are the most effective way for controlling wolf depredations. So we'll circle back to the growth of the Wisconsin wolf population counting system. So does the Wisconsin DNR know how many wolves are in the state? And we pointed out that 40-year period we had minimum counts that ranged from 14 to 1,034 wolves. This would represent the minimum number of wolves known to exist in Lake Winter by these survey methods. And so here again is that population growth as it is occurring over time with that minor decline. And this count is done at this time of the year. So again, yeah, if you're asked to say, well, there's 2,000 wolves in Wisconsin. For a while in April, there are 2,000 wolves in Wisconsin. But if you're complaining about the DNR's count, that represents the population at the very minimum end of the annual cycle. So that's going to be a more conservative number. And again, this is the minimum counting system. When we go to this population estimation system, it's a little bit higher than that. But still, for most part, I think these numbers are fairly reasonable. This is the map we looked at earlier, just showing distribution of wolf packs across the state. And up until 2020, all the counts were done by individual wolf packs. So the DNR now is shifting to this patch occupancy modeling system, which is a statistical approach, and it looks at the landscape and determines whether areas are occupied or not. It still relies on snow track surveys, and verified observations to determine where wolf ranges across the state and the average pack size. And it uses radio collared wolves to determine average pack areas. But it makes a statistical estimate, and so it accounts for areas that are under-surveyed and not being adequately surveyed by looking at the density of wolves within areas that are surveyed and knowing similar characteristics of areas outside those areas. You can still make estimates. So the minimum counting system always depended on just animals actually counted. But if an area didn't get surveyed well enough, you might be missing some animals. And it provides incredible intervals, which with one of the weaknesses of a minimum counting system is that it doesn't have that. So like this shows the minimum counts for 3 years and the patch occupancy modeling. Again, so those numbers are a little bit higher. These are minimum counts for wolf population. These are patch occupancy modeling estimates with a standard deviation and a 95% credible interval. So the minimum counts kind of fall in the lower portion of those credible intervals. So this patch occupancy modeling is a good way to go when you get to a much higher wolf population. Minimum counts work very well when you've got a few hundred animals, but when you get over 1,000 animals as we're approaching now, it's a much more difficult system to measure. And the patch occupancy modeling accounts for uncertainty in the population estimation methods. It averages about 14.5% higher than the minimum counts, but the minimum counts do fall within the 95% confidence intervals, and both estimates provided undercount of lone wolves in the population, which are always very difficult to determine. But for most part, the estimates are probably reasonable estimates of wolves living in Wisconsin at a specific time of year in a wolf range of Wisconsin. And those are more or less what the numbers mean. Neither method adequately accounts for all the lone wolves, but lone wolves within wolf range probably still get captured by this. But if there's a lone wolf living outside of Madison or traveling outside of Madison or outside of Milwaukee, neither system actually counts for those wolves. And in any case, all wildlife estimates have levels of uncertainty to it. And I think compared to as many other wildlife service survey methods, this is probably as accurate a system of surveys that we can get on a wildlife population. People who don't like wolves, the count is always DNR's underestimating. And people who love wolves, the DNR may not be getting an accurate measure as well, or we're saying there's more wolves than they think there really are. I just saw a presentation the other day that suggested the population currently may be down to as low as 380 wolves. I don't think that's really likely. I think the winter hunt we had in 2021 maybe reduced it some, but I don't think it reduced to that level. So just overall, what we can say about wolf numbers in Wisconsin, the wolf population is not exploding, but seems to be stabilizing. Wolves are one of many mortalities on the deer population, and healthy population of deer continue to live in northern Wisconsin. Wolves are a risk factor on hunting dogs in summer, but rates of attacks on pet dogs are relatively low. Cost of wolf depredations have mostly stabilized. Wolves can be hunted at sustainable levels, but other factors need to also be considered in planning wolf hunts. Targeted lethal controls will not endanger the state wolf population, and Wisconsin DNR has a good estimate for wolf numbers in winter within areas of occupied wolf range. And with that, we've got a few things that just share on sharing the land with wolves, things that people want to encourage people to do. Don't feed wolves or feed pets outside areas of wolf range. Avoid feeding deer in areas that might attract wolves. Don't allow dogs to run at large in wolf areas. Turn lights on and accompany dogs going outside after dark. Avoid den or wolf kill sites with dogs. Learn wolf sign tracks and scats and other signs in wolf areas. Don't leave carcasses of dead animals exposed at home or farm sites. And stand tall when breastfeeding wolf that's not showing normal fears. And report any bold or tame acting wolf to DNR. And with that, I guess we open up to some questions. Yes?
So on that map, we have the northern range of wolves, and all have the central territory, and there's a gap. Is it because we have no surveying it, or why is that gap?
Well, the farm country.
Huh?
The farm country. So wolves are living mostly in the forested, heavily forested areas. Yeah, and so where farm areas are more marginal habitat for wolves. So yeah, when we first started getting wolves in Wisconsin, the initial recovery plan for Wisconsin in 1989 just planned for wolves in the northwoods. And then all of a sudden in 1994, 95, you start seeing them in the central forest. They found their way out to the central forest region. Now, if you're familiar with the central forest region, you get in the middle of the central forest and it's as wild as places in northern Wisconsin. So they do best in areas with lower density of roads, lower presence of people, heavily forested areas. Anyone else? Yes.
So what is the explanation for the observation that the deer are all gone and we can't?
There could be many. And if I knew more about the specifics of the site, we could talk about how has this forest changed in the last 40 years? What's been a climatic pattern in this area? What are the other predator populations like in this area? How does this area fit into the local packs area? Is this near the middle of a pack, or is it, we could probably look at a lot of different things. So I can't give you any one answer why they're not seeing deer. They're also getting older. Maybe they're not hunting as they used to be. But a lot of times the forests are getting older, and people start hunting these areas when they're young, aspen forest areas, which are just prime deer habitat, and then they become a sugar maple hardwood forest, and they're pretty poor deer habitat. So depending on the cutting practices, the management of the area, baiting practices can be a big factor. If they're not baiting, their neighbors are baiting, they're probably not going to see as many deer. So, and even baiting itself can change whether wolves are active or deer are active during the daytime. If you're feeding a lot, they get filled up during the daytime, they sleep all night, all day, and they're feeding at night. So you're just not seeing as many deer in the landscape. Yeah, in the back.
So what was the current carrying capacity for the wolves? Because you said it's kind of stabilizing at this point.
Yeah, the estimate was 1,242 in a research project done by Jim Stendlin in 2015. And we did some estimates in the mid-1990s. At the time, we were estimating about 500. And when the DNR's first recovery plan was done in 1989, the estimates were about 100, 150. So our concept of what the carrying capacity is has changed over time. But if we look at the growth of the wolf population, it looks like somewhere in that 1,200 area might be about where we're at, depending on whether we're using population estimation or our minimum count. We're getting close to that number.
To follow up with that, with the management population, like when we were looking, when the hunting seasons were in play, what was the number they were trying to manage? Was it 850? What was that number?
There was an overall goal of 350, but there was not an intent to manage for that number. It was just done on a year-to-year basis. That in 2012, the plans were to stabilize the population. The first year was going to be 100. 2013, the plans were to reduce the population by about 15%, assuming that we reduce some of the conflicts of wolves, but it knocked the population further than what they thought it was going to, so in 2014, they again tried to stabilize the population. So it was done on kind of a piecemeal based on a year-to-year basis.
But again, that was like between 600 and 800 wolves. Now that we're at 1,200, right? They had the hunting season last year. They only allowed so many wolves to be harvested. What I'm asking is, what is that target number that they're looking for based on the recent hunting studies that have been done?
Well, right now, the DNR is working on developing a new management plan, and they're going to be coming up with a draft of that plan sometime this spring, and that will determine what the new goals for the state are. The existing plan, which is a 99 plan, was a population goal of 350. That was under the assumption we had a carrying capacity of about 500 wolves in Wisconsin. So, with knowing now we've got carrying capacity for probably 1,200 some wolves, and if you try to reduce the population of 350 wolves, you're basically saying we're going to remove wolves in 2/3 of the landscape. Because there's no way you can get down to 350 without drastically eliminating wolves in a lot of places.
Still is the population.
Yeah. Yes.
I got a hold of the former teacher. He said it was either Jackson or Clark County.
Okay.
Hunted.
Okay.
So they didn't know which one. Those ones is kept.
Okay. Yeah, the central Wisconsin, but yeah, there's been a pretty good growth of population there. Yeah, I guess it depends too, you know, where they are in the wolf pack area and what the habitat's like now and what it was like 40 years ago. And
So this would be another good thing to bring up with kids, that, okay, we have a correlation there between increased number of wolves and I don't see any deer anymore, but is that the cause of it? What are some other causes that there could be? What are some alternative explanations? Oh yeah, that might make sense too, but for kids to see that difference between correlation and causation,
Yeah,
like they were talking about lunch with.
we have any hybrids in Wisconsin, so on the east coast.
yeah,
It's pretty much all coyotes now.
right, yeah. Whether they're the coy wolves are coyotes eastern coyotes that originated from the Great Lakes region, and when the forests were cut over in the northern Great Lakes region, and coyotes moved into areas that had not had coyotes before, and they continued eastward into Ontario, they bred with smaller eastern wolves that live in southern Ontario. And as those coyotes continue spreading further eastward, they carry those eastern wolf genes with them. So they end up being a bigger coyote than what we have here. The coyotes in our region are not readily hybridizing with wolves. We have had cases of wolf-dog hybrids in the wild, but with those we assume are mostly cases of people having bred them in captivity and they either escaped or were dumped in the wild. But it's been illegal since 2010 to own wolf-dog hybrids in Wisconsin, and since then we're seeing a lot less of those getting dumped in the wild or escaping into the wild. Yes?
You know, I agree with livestock and stuff. I have sheep and we have coyotes, but the coyotes have never bothered the sheep. So are there certain wolves that, you know, our belief is don't get rid of these coyotes because they're good ones and
Sure.
So same thing with wolves?
Oh, very much so, yeah, and, you know, that, so less than 15% of our packs do depredate on livestock, and there's lots of farms. We average about 30 farms per year that have livestock depredation. And there's lots of farms in those wolf areas, and I drive by farms all the time and I think, oh, I've never heard of a depredation at this farm. So it's, yeah, I'm sure it's situational differences. Some of it is the management itself. Guard animals with sheep are so extremely useful. The fencing is really critical as well. But yeah, if you have a pack living there that doesn't kill sheep or livestock, it's best to just keep that pack there. In fact, disrupting that pack might increase the risk that you will start having problems because the new coyotes coming in might, you know, may not have that same respect for sheep. Yeah. Yes?
So, when we talk about wolves, we often talk about the deer as their major prey source.
Yeah.
And we would be looking at population models and data for deer and wolf and making correlations. Is there a correlation? How many fawns do they have in the northern region versus southern region? We'd be looking at a lot of the data. Again, diving into the largest population of wolves is always which correlates when fawns are being born, which is correlating with, again, there's a lot of data that I'd like to investigate for students to be able to make their own conclusions.
Sure, yeah. All neat stuff to look at. Of course, with southern Wisconsin, you've got habitat differences too.
Yeah.
And the deer that are living in farm country, they just have a much better nutritional base than wolves living in, or deer living in forested areas. So the deer living in forested areas, they have poor nutrition, adequate nutrition to support deer, but they don't have the really high nutrition of the agricultural area. So yeah, typical ag areas, you have higher counts on fawns, and then also weather conditions. So the snows are a big limiting factor for wolves in north, or for deer in north Wisconsin. So deer are going to have smaller litter sizes after severe winters, better litter sizes after milder winters. So yeah, there's a lot of other relationships to also look at: the climate, the habitat conditions, the land use patterns. All are going to be factors that affect the deer. And then in southern Wisconsin, we've got a lot of deer affected by chronic wasting disease, which is almost non-existent.
So if you are interested in getting more information on wolves or other natural resources problems here in Wisconsin, Wisconsin's Green Fire sponsored this presentation, and we'll put these back so that you can take some. And it's a group of scientists and some educators that are working to make sure that the science gets out to the public and is also included in policy decisions. So,
We've got these, yeah, wolf posters.
and also to the
Well,
local
if you want
Here in
experts,
Brooksville.
students, you're welcome.
but the scientists working on many, many different natural resources issues are willing to help you if you have questions, if you want some data sources, what kind of phenomena. So contact information is in these folders, and you are welcome to help yourself to them. And use the expertise of people that have worked for decades in the field and still keep up in it and are willing to put themselves out and help you with issues. And Dolly, and myself are co-chairs of the education committee and trying to get the word out that we're here to help.
Yeah, and we can be that bridge